There are three that basically do all of the work. The first one is a static body 2D. This is a, well, static physics object. It doesn't move, and it's basically for objects like houses, trees, bins, really whatever doesn't move and needs to be collided with. Next up, we have a character body 2D. This is a physics object that can be moved via code. Pretty much any kind of character is going to be a character body 2D. This could be the main player, this could be enemies, this could also be a car, really anything that moves and doesn't have to be physically accurate while moving. More or less anything that moves and needs to collide with something is going to be a character body 2D, with some minor exception. The most important one is for rigid body 2Ds. These are physics objects that can be moved via physics. These are going to be used for arrows, cannonballs, and things like that. And just to be explicit, the difference between a rigid body 2D and a character body 2D is that a rigid body 2D gets some code in the beginning to determine the direction of the movement, and then everything else is covered by physics. Whereas a character body 2D is going to continuously get directions from the code, meaning these objects can be updated constantly. Besides these three nodes, there's one more node that you see very often, and that is an area 2D. This one simply checks if a body is in an area, and that's all it does. On its own, it doesn't do any kind of physics, but it works very similar compared to the others. As a consequence, they are usually grouped together. And before we get started, there's one more super important thing, and that is that physics objects are not moved via their position. Instead, we're giving them a velocity, and then Godot calculates the position. Via that system, Godot can account for physics right away. First of all, I want to create a static physics object. We can actually use the exercise object for that. Now, at the moment, we have a node 2D at the root node. This I want to change. For that, I want to right-click on it and then change the type. If you now look at all of the nodes, we can go to node 2D, and in there, we have a collision object 2D. If you expand that, we have an area 2D, and we have physics body 2Ds, where we have a static body 2D, a character body 2D, and a rigid body 2D. The nodes I just talked about. These are the main physics objects. Although they're not the only ones. If you expand static body 2D, you also have an animatable body 2D, which is basically a static body 2D that can be moved a bit. And if you expand rigid body, we have a physical bone 2D, which is going to be useful for skeleton animation, but not something we need at the moment. So instead, I want to work with a static body 2D. Click on Change, and now Godot is going to complain. To work with a static body 2D. Click on Change, and now Godot is going to complain that this node has no shape. As a consequence, it cannot collide or interact with anything. To fix that, we have to add another node, either a collision shape 2D or a collision polygon 2D. To get started, I want to add a collision shape 2D. If we add that, Godot is going to give us another warning that a shape must be provided. With the node selected, you want to look at the inspector, and there we can add a shape. Loads of options in here. Choose what you think is best. Usually a rectangular shape 2D is working the best. And I guess just to keep things simple, we can get rid of the box and of the second tree, and then change the shape of this thing so it fits the tree reasonably well. And by the way, if you hold Command or Alt, then you can scale this thing while mirroring it around the axis. This works on X and Y. And
we've all been there, typing
create the box like so. Cool. With that, we have one physics object. If you now look inside of the game, we have a tree, basically. That being said, at the moment, we are still not getting collisions, and if I run the game, the tree just doesn't do anything. For actual collisions, both the player and the tree need to be physics objects. At the moment, the player is simply a graphic that can move around. No collision yet. Now, before we start working on the player, inside of the tree, in the script, you want to make sure that you are extending the right node. At the moment, node 2D is incorrect because this is a static body 2D, meaning this should be static body 2D as well. Without that, the code would start doing weird things. Now, that being said, this exercise object doesn't need to do anything anymore. We can remove the script entirely and close the script. We can simply discard it. That way, we simply have a tree. And I guess while we are here, we can rename it to tree. And just to be consistent, inside of the scenes folder, this shouldn't be exercise object. This should be tree. And the script, so exerciseobject.gd, we can delete. Remove it, and then the game is going to be a bit cleaner. Now that we have that, we can start working on the player. First of all, the player root node needs to change the type. We want to have a character body 2D. Once again, Godot is going to complain that we have no collision shape. This we can change by adding a collision shape 2D and then giving it a shape. For the player, I want to go with a rectangular shape and then scale it so we are hitting most of the player. You want to leave a bit of space at the top and at the bottom because these parts should overlap with other objects. That way you get a fake kind of 3D effect. Looks really nice. You see later what I mean. Besides that, what's really important to do inside of the script, we want to extend a character body 2D. And now that we have that, inside of the game, I can move the player around, and we still don't have collisions. That is because at the moment, we are changing the position of the player via the position property, which you can do. You wouldn't get an error, but you also wouldn't get collisions. The way you are supposed to approach it is you are supposed to override the velocity, which is a property of a character body 2D. This needs to be moved in a certain direction, which we are getting via direction multiplied with the speed. Once we have that, you want to call move and slide. That way, it applies this velocity and actually moves the character body 2D. As an outcome, the player is going to move a lot slower. That we can fix by changing the speed back to 200. Might actually be a bit too fast. But now the important bit is we have a collision with the tree. So I cannot go further than this tree, and that is working really, really well. That is all we needed for collisions. For the player, we have a character body 2D, which we are moving via the velocity and move and slide. Besides that, we have a tree, which is simply going to be a static object with a collision shape. We also have an image, but that isn't actually necessary. At least for the collision. For the actual game, this is important. So with that, we have a pretty good system. To finish up this part, let's do an exercise. I want you guys to restrict the player to the map, or in other words, use static bodies that ensure that the player is not able to leave the screen. Pause the video now and see how far you get.
What if your game's story could scale?
game scene. I want to add a new child node, which is going to be a node 2D. Let's call this one borders. To this node, I want to add a static body 2D along with a collision shape 2D. For the shape, I want to add a rectangular shape. That way, once again, we're getting the shape and the player is not able to move past that. So here, we cannot go further up. And this shape, I want to move to the right. So we are here on the right border of the map. And then I want to scale this thing up by a lot. So the player cannot go further to the left and leave the screen. Let's try this one now. And the player is not able to leave. This we have to do for all of the 4 sides. Although you do have to be careful. If I simply duplicated this static body 2D by clicking on duplicate or Control D, then we would get another static body 2D that we can move to this point here, and that would work. I can now run the game, and the player cannot go further to the right than this border. The issue is, if I wanted to change this collision shape, I would also change the other one. If you duplicate a static body 2D with the collision shape, these collision shapes are going to be linked, which sometimes can be useful, like in this case, where we do want to have the same shape. And this one should be a bit further here. But for the top and bottom bit, this would not work. So do be careful here. Instead, I want to add another static body 2D with another collision shape. And for this collision shape, I want to create a new rectangular shape that is going to be all the way at the top here. And let me move it to the right position here. And here is fine. Finally, I want to duplicate this shape and then move it all the way down. So we are covering the final part of the map. And now the player is not able to leave the screen in any direction. Perfect.
Wait, so all the AI editing I learned before was pointless? With Dream.
Next up, we are going to animate the player, which is going to make the entire thing feel much more dynamic. In Godot, there are a lot of ways to animate things. The easiest one is to use an animated sprite 2D, which is a sprite 2D that's, well, animated. Inside of this node, you can create animations and then select them. That's pretty much it. Let's have a look. Back in Godot, I want to work inside of the player and then get rid of the sprite 2D. Instead, I want to add an animated sprite 2D, which at the moment is going to give us a warning that we have to add sprite, which at the moment that's, well, the easiest one is to use an animated sprite 2D, which is a sprite 2D that's, well, animated. Inside of this node, you can create animations and then select them. That's pretty much it. Let's have a look. Back in Godot, I want to work inside of the player and then get rid of the sprite 2D. Instead, I want to add an animated sprite 2D, which at the moment is going to give us a warning that we have to add sprite frames to it. For that, you want to look at animation and then inside of sprite frames, create new sprite frames. This right now doesn't really do anything, but if you click on it again, you want to look at animation and then inside of sprite frames, create new sprite frames. This right now doesn't really do anything, but if you click on it again, then you're getting a sprite frames editor. In there, on the left side, you can see the animation that you want to play. Let's say for now, I simply want to play the left walking animation for the player. Then inside of this main field, you can play the actual animation. This you can create in basically two ways. Number one is you could simply drag graphics in here. For example, if I grab a couple of these random objects and drag them in there, I can play the animation, and then Godot is going to play one frame after another. Which would work, but for our purposes, this isn't ideal. Let's undo all of this. Instead, for the player, we have a player tile set. If I drag it in there, you can see that we have all of the player frames in this kind of setup. And from this, we want to select specific frames, like for example, this graphic here. To work with that, inside of the sprite frames, you want to click on this symbol, where you can add frames from a sprite sheet. We want to go to Graphics, Player, and then select the tile set or the sprite sheet. And then we can zoom in by holding Control and using the mouse wheel. Frames. You want to click on this symbol, where you can add frames from a sprite sheet. We want to go to Graphics, Player, and then select the tile set or the sprite sheet. And then we can zoom in by holding Control and using the mouse wheel. Godot wants to separate this graphic into specific cells. We have 4 horizontal cells, but only 3 vertical ones. The size lines up pretty well, so this looks pretty good. And now we have to select the right kind of frames for the animation. At the moment, we want to get the left animation, which is the left one. And if you click on it, you're getting a number. This would be frame 0, then we have frame 1, and then frame 2. These are the 3 frames that I want to add to it. And now we can play this animation. Although at the moment it doesn't look great. This animation is actually supposed to have this frame, then this frame, then this frame again, and then the final frame. To get that, you can simply have the first frame selected, then press Ctrl C and Ctrl V, and now we have duplicated the frame. And to move this frame, you can either move it in the right position or use these arrow keys. That way, we can move frames around quite easily. We are getting a much nicer walking animation. You can also set the frame rate, if this thing is looping, and if it's auto-playing. You can also set the frame duration, but I don't really care about any of those values. Just make sure that you are looping the animation. Otherwise, it would simply stop on this frame. Also for now, I want to autoplay this animation. And that way, if I run the game, we are getting a very basic animation. That is looking pretty alright. And now to work with this, we want to use GDScript, and to keep things organized, I want to create another function for the animation. No need for parameters. I basically want to check if we have a direction, then we want to actually play the animation. If we don't have a direction, then the player should be static, or in other words, we only want to get the first frame. That way it looks like the player is idling. If we have a direction, I want to play the animation, which for now means we are simply not doing anything because we already have an animation, it's just not doing the right thing. However, if we don't have a direction, so we're not moving, then I want to get the animated sprite and update the frame property. This one should always be 0. Now by default, this value increases, so we are selecting different frames. But if you set it to 0, we're always sticking on the first frame, so this one here. That way, at the very least, we can play the animation or not play the animation. Really important, don't forget to actually call this animation function, which I want to do before we are doing move and slide animation, although the actual position of animation doesn't matter. Anyway, let's try this now. If I am not moving, the player is also not animating, but if I start moving, then we are getting the walking animation. And that is working pretty well. Next up, I want to get the right walking animation. For that, you could add another animation in here. So simply add another animation with right, and then select the player and the right movement. So these frames here. However, we don't actually have to do that. We can approach this much more elegantly. So let's get rid of the right animation. Instead, all that we have to do, if the player is moving to the right, we want to flip this animated sprite on the horizontal axis, which we can actually do super easily. With the animated sprite selected, we have offset, and there we can flip H. And if you hover over it, the property is called flip_H. Inside of GDScript, what we can do, if direction.x is greater than 0, then the animated sprite 2D dot flip H property should be true. Let's try that. If I go left, we're looking left, and if I go right, we are looking to the right. Now, if I look left again, we're not going back to the left side. So that's not great, but H property should be true. Let's try that. If I go left, we're looking left, and if I go right, we are looking to the right. Now, if I look left again, we're not going back to the left side. So that's not great, but at the very least, we are making progress. To fix this part, all we have to do is add an else statement and then copy all of this with the difference that flip H should be false. Let's try this again. And now we're getting the left animation and the right animation, and that is working really well. definitely progress. Although we are trying to do something very simple and we are using 4 lines of code for it. This could be more elegant. The way to approach that is to first get the animated sprite 2D and then flip H. The value we want to assign to it is going to be direction.x being greater than 0. And then we are done. This line is doing the same thing as these 4 lines. And I think it's much easier to read as well. So let me get rid of these 4 lines, try this again, and we are getting the same result. Doing this kind of stuff comes with experience. If you work inside of an engine for long enough, then at some point you find ways to make your code more efficient. So for now, if you work with more if statements, that's totally fine, but this would be more elegant and much easier to read. With that covered, let's do another exercise. I want you to finish the animated sprite, which means you should be adding the logic for going up and down. So in other words, select the right animation depending on the player movement. Pause the video now and see how far you get. Also remove timer 2. Godot added the 2 because you cannot have the same name for two nodes. The timer that we have created should be called the car timer. And for now, I want to disconnect this signal, which you can do by right-clicking on it and then disconnect. Also, inside of the script. And for now, I want to disconnect this signal, which you can do by right-clicking on it and then disconnect. Also, inside of the script, this timer function should disappear. We're going to replace it in just a second. For now, I just want to have a clean start. On top of that, the finish area 2D can go inside of borders. I think they kind of work together. And finally, this exercise object should just be a 3. That's the better name for it. Of that, the finish area 2D can go have a clean start. Should disappear. Disconnect created should be called the car timer. And for now, I want to disconnect this signal. We can start working on. For that, number 1, we have to create a basic car scene. This is you want to keep it as organized as possible. Now that we can create a working timer, we can start working on spawning the cars. For that, we have to go through a couple of steps. And along the way, we are going to learn how to spawn scenes via code. In other words, we want to create instances of a car whenever a timer triggers. For that, number one, we have to create a basic car scene. This is going to happen in the normal way. We are just going to create a new scene with a sprite and an area 2D. After that, we're going to store the car scene in the main game. Next up, when the timer triggers, we're going to create one instance of that car scene. And finally, we can attach the car scene to the current game scene. That way, we can actually see it. First of all, inside of Godot, I want to create a car scene. Add a new scene, and the root node is going to be an area 2D. This area 2D, by the way, I have used because there are no actual collisions between the player and the car. Whenever there's any kind of collision between the two, the game is ending right away. So an area 2D here is totally fine. To this area 2D, I want to add a sprite 2D so we can see something. The graphics for that are going to come from cars. Select one of them and then assign it to the texture of the sprite 2D. Then we are getting one car. After that, for the area 2D, I want to add a collision shape 2D, which for this one can simply be a rectangle shape. Make sure you cover the whole car, like so and so. Guess kind of like this. Doesn't have to be too precise for our purposes, but obviously for a real game, do spend some time on it. All of this I want to save as car.tscn, click on save, and now we have one car. That actually should be renamed to car, and then inside of scenes, I should have done that before. This shouldn't be area2d.tscn, this should be renamed to car.tscn. Much better. Now we have a car scene. This I want to spawn inside of Godot whenever this car timer triggers. Speaking of which, for this one, wait time should be 1 second for now, and it should auto start. After that, for node, I want to go to timeout once again, and then connect onCar timeout timer to the game script. And now we get onCar timer timeout. Whenever this thing triggers, we want to create one instance of the car scene and attach it to the game. For that, we already have a car scene. So next up, we have to store the car scene inside of the game scene, which we do all the way at the top. I want to create a variable car underscore scene. The data type for this one is always going to be a packed scene. You are getting it by preloading the car scene. Godot is now giving you all of the options of data that you could preload. In my case, I want to get scenes and car.tscn. That way, let me add just a bit more space. We have the car scene ready inside of the game scene, which means we have covered the second part. Next up, we have to create one instance of this car scene, which is going to happen every time the timer triggers. To create one instance of the car scene, we have to call instantiate. That way, we are creating an instance of it, which we want to store in another variable. Let's call it car. That way we have one instance, so we have covered the third step. Instance of the car scene, we have to call instantiate. That way, we are creating an instance of it, which we want to store in another variable. Let's call it car. That way, we have one instance, so we have covered scene, which is going to happen every time the timer triggers. To create one instance of the car scene, we have to call instantiate. That way, we are creating an instance of it, which we want to store in another variable. Let's call it car. That way, we have one instance, so we have covered the third step. Finally, that way, we have one instance, so we have covered the third step. Finally, to actually see the car, we have to attach it to the current scene. This happens via add child. I want to add the car, and then I can run the game, and we should be seeing the car somewhere around the origin point. So there, we are getting the car. On top of that, with the game still running, you can look at the scene tree, and there we have remote, where you can see the nodes in real time as the game is running. And there you can see Godot keeps on adding area 2Ds to it every time the timer triggers. Besides that, you can see the nodes that we have added ourselves. So this is a real-time view of the game. And well, you can see quite well that we are adding more and more cars. Inside of the game, you can't see them because they're all in the same position, but that we can work on. Inside of the car scene, I want to add a script to it. The defaults here are fine as they are. And then for the car, I want to add var direction, which is going to be a vector2 that at the moment points to the left. Besides that, I want to have var speed, which is going to be 100. After that, I want to call func_process, in which we are updating the position of this area 2D node. So once again, inside of transform, we can update the position of this node. Like we have done in the beginning of this project, I want to get the direction multiplied with the speed. And you might be wondering now, why do I use process for the car, while for the player, I used physics process? And well, for the player, we have collisions, so we want to include physics. Whereas for the car, we don't actually have collisions. Once again, as soon as there's a collision between the player and the car, the game ends right away. So we don't actually have collisions, we are simply checking for an overlap. In practice, you could also use physics process. It doesn't really matter for our purposes. But anyway, with that, we should have the car movement, although I think 100 is a bit too much. Let's go with 2. Let's try out of this now. And there should be a car going to the left. And that is looking pretty good. Perfect. Once again, if you look at remote in the game, you can see we are adding more and more car scenes to the game. That being said, there is a bit of a problem. Number one, adding the cars to the game scene is going to clutter the scene tree a lot, which is going to make it difficult to work with. So what we can do at this point is add another node 2D that we can call objects. All of the objects in the game are going to be inside of this node 2D, including the player and the tree. Add them in there, and then, inside of the script, I want to add the cars to these objects as well. You can simply drag and drop objects in the right position. Don't forget the dot. And now we're adding the car to the objects node. If I run the game, drag and drop objects in the right position. Don't forget the dot. And now we're adding the car to the objects node. If I run the game instead of remote, all of the cars are going to be inside of objects. If you minimize it, this looks a lot cleaner. Once again, not something you have to do, but it's going to make your life quite a bit easier. Besides that, it's actually not a great idea to spawn cars indefinitely. So at the moment, we keep on adding more and more cars. And this goes on forever. It never stops, which isn't great for performance, because once a car leaves the screen, it shouldn't be there anymore. You can't see it, you can't interact with it, it should just disappear. And think of a more complex game. The more objects you have, the slower the game is going to run. So you want to keep the amount of objects as low as possible, which is generally a good idea. In other words, for the car, as soon as the car leaves the screen, we want to destroy it. That you can do by adding another node, which is called a visibility screen notifier 2D. This can check if node is entering or exiting the screen. It should roughly fit the texture, that looks alright, it doesn't have to be too precise. And then, inside of the signals, you can check if the screen was entered or exited. We care about exited. If I connect this to the car scene, we want to destroy the instance of the car scene as soon as it leaves the screen, or when this function is triggered. This in Godot you are doing via Q3. This destroys the current instance of the node. Or in other words, if I run the game again and go to remote, inside of objects, we only ever have maybe 2 cars. As soon as the car leaves the screen, we are destroying it. So we only ever have that many cars. And inside of the game, you can see we only have 2 cars on the screen, maybe 3 cars sometimes. That way we are making sure that we only ever have so many cars on the screen, which is going to be really good for performance. Now obviously for our game, since it's really simple, it doesn't really matter, but it's generally good practice. Besides that, I want to set start positions for the cars. At the moment, the car always starts in the origin point, which obviously isn't great. To fix that, I want to add another node 2D to the scene tree that I called car start positions. In here, we want to store a couple of nodes that have the start position for the car. For that, you could use a node 2D. It would work, but Godot also has a marker 2D that works a little bit better. So with this marker 2D, if you move it, you can see that we have the origin point along with this cross around it. So it's a little bit easier to see. But outside of that, we only really care about the position of this node, and this we are getting via transform and position. These marker 2Ds, I want to move to all of the car lane start positions. Left or right doesn't matter so much. You can alternate or you can stay on one side, whatever you think is best. So let's do this again, like so and like so. And then we have a start position for every lane. Once we have that. As soon as we have a new car, we want to update the position of that car. For that, first of all, I want to get a random marker from the car start positions. Let's store that in a new variable, position marker. The way you're getting that is, first of all, you want to get the car start positions and then get children. This is going to return an array with all of the child nodes. On an array, you can call the method pickRandom. That way, you're picking one random child of car start positions. And once we have that, we can get the current car and update the position of that car. Now, right now, you don't get position as a suggestion. That is because Godot doesn't know what kind of node this car is that you have just instantiated. If you want all of that, you can add s and then the type of node that you want to create. So in my case, an area 2D. That way, if you have car, you can get all of the suggestions again, which can be super helpful. And generally, being really picky about the right data type is a good idea. It can make your life much easier. Anyway, for the car position, I want to have the position marker, and don't forget, position marker is just a node. On this, we want to have the position as well. If you want to be super precise here, this could be S marker 2D. If I now run all of this, we should be seeing a car coming from the right. And that is working pretty well. If we go further down, there are also some cars that can also disappear, and that looks pretty good. The issue now is on the left side, we can't see any of the cars. Simply because if a car starts here, for example, it only goes left. Not great for our purposes. Super precise here, this could be S marker 2D. If I now run all of this, we should be seeing a car coming from the right. And that is working pretty well. If we go further down, there are also some cars that can also disappear, and that looks pretty good. The issue now is on the left side, we can't see any of the cars. Simply because if a car starts here, for example, it only goes left. Not great for our purposes. But that we can work on. Inside of the script for the car, once the car is ready, or in other words, func_ready, we can simply check if position.x is smaller than 0. If that is the case, we know we are on the left side. If that is the case, direction.x should be 1. That way, we're turning the vector left to a vector right. Although, if I run the game now, this is not going to work. We are still getting the cars on the right side, but we have no cars coming from the left side. The issue is that this ready function only runs before we are updating the position. Or in other words, the ready function, this one here, is called when you're adding a node to a scene, which currently happens on this line when we are calling add child, which at the moment is a bit of a problem because we are adding the car here and the current position of the car is 0 and 0. And then we are running this line here, which is never going to trigger because the position is 0 and 0. Only after we are doing all of that, we are setting the position of the car. As a consequence, this if statement is never going to trigger. I can actually demonstrate. I want to print car direction. Let's run it, and this function is never going to run. So this doesn't do anything. Fixing that, fortunately, is very simple. We want to update the position of the car before we are adding it as a child to the scene, which is totally fine to do. When we are calling this ready function, the car already has the right position. And that way, we should be getting cars coming from the left as well. So there we get car direction. I just have to find it. There we have the car. This can be kind of annoying in Godot. Understanding when these inbuilt functions are being called sometimes can be a little bit tricky. Always remember, ready is called when you're adding the node to the scene tree. And while we are here, I don't want to print something when that happens. Instead, I want to get the sprite 2D and flip H should be activated. That way the car is pointing in the right direction. And with that, we should be having cars that go reasonably well in both directions. At some point, there should be one coming from the right as well. Let's look up here. That definitely works. This we can refine, but I think for now, this is working reasonably well. Now, before we continue, there's one important topic that we do have to cover that does get a bit more technical. Frame rates and delta time. So far, we did technical. There's one important topic that we do have to cover that does get a bit more technical. Frame rates and delta time. So far, we did not care about the frame rate at all. The game simply worked. And that's totally fine. However, in some instances, this can be an issue. That is because the frame rate is affecting the movement of objects. Not always, but in some circumstances, and that we have to talk about. And while we are here, inside of Godot for the car, when we are calling process, we are getting delta. Same for the player, inside of physics process, there we also have a delta. And so far, I just didn't talk about it, but it's a really important parameter. But let's go through it step by step. Now, the main issue is that a frame rate that when we are calling process, we are getting delta. Same for the player, inside of physics process, there we also have a delta. And so far, I just didn't talk about it, but it's a really important parameter. But let's go through it step by step. Now, the main issue is that a frame rate determined movement can be inconsistent. Here's a table with the same movement, but different frame rates. The actual speed is the first column, where we always want to move at 10 pixels per frame. Or in other words, inside of our game, for the car for example, we are moving the car by a certain direction multiplied with a speed. In our case, for example, this would be a speed of 2 on the horizontal axis. This change in position is applied on every single frame. So effectively, we are moving at pixels per frame. Besides that, we have the amount of frames per second. This number is going to vary on the computer. If you have a really slow one, you might only get 10 frames per second. If you have a really good computer, you might get 500 or more frames per second. This also depends on what happens inside of the game. If you have a lot of objects, the game is going to be more difficult to run. Generally, you want to have 30 or more frames, that way your game is going to feel smooth. But for this example, it doesn't really matter what the number is. What does matter is the final column, where we get the pixel movement per second. This is simply the multiplication of these two numbers. For example, if we are moving at 10 pixels per frame, and we have 10 frames per second, we are moving at 100 pixels per second, which on its own would be totally fine. But the issue is, depending on different frame rates, we're getting a different speed because we are applying a change in position multiple times per second. And this number varies. If we apply the change in position 10 times a second or 500 times a second, it's obviously going to be different. Which for our game is going to be a problem because, well, you can see it here. If our pixel movement is 100 pixels per second or 5000 pixels per second, the game is going to feel significantly different. Or in other words, the movement speed of your game will change depending on the computer. And this is really, really not good. Just imagine any game where the movement speed could either be 100 or 5000. No game would work like that. And as a consequence, we have to account for it, which we are doing via delta time. All that this concept describes is the difference between the current frame and the previous frame. Or in other words, it tells you how long it took your computer to render the current frame. Doesn't sound that important, but it's actually super useful. Because imagine you have a game that runs at 30 frames per second. Then delta time is simply 1 divided by 30 or 33 milliseconds. If you have different frame rates, then you get different numbers, obviously. The specific number here doesn't actually matter. What matters is that the higher the frame rate becomes, the smaller delta time will be, which is incredibly useful because let's do the table again with delta time. The first three columns are what you have seen before. The only addition now is that we have delta time. For example, if our frames per second are 10, then delta time is 1 divided by 10 or 0.1. If our frame rate is 30, then delta time is going to be 1 over 30 or 33 milliseconds. All of that is useful because delta time and the frames per second effectively cancel each other out. Imagine this formula here written in a slightly different way, where we have 10 pixels per frame from here multiplied with the frame rate. In this case, that's 30 frames per second, this number. And this we are multiplying with delta time. This number here, 1 divided by 30, or 1 over 30. The end result has to be 10, for the simple reason that 30 and 1 divided by 30 are simply going to be 1. The only thing that's left is the 10 that we are getting at the end. And this works with all of these numbers. So if we have 60, we would have 60 multiplied with 1 over 60, 500 multiplied with 1 over 500, and so on. Frames per second and delta time cancel each other out. The only thing left are the pixels per frame. And that is really all we want. That way, it doesn't matter what the frame rate is, you're always getting constant movement. And this you should use whenever you change the position or rotation of any node. The one place where you don't have to use it is with physics bodies, because for those, Godot automatically applies delta time. And finally, let's do all of this in Godot. That way all of this can also be a lot more practical. We want to work inside of the car, where at the moment, we are updating the position by getting the direction and multiplying it with the speed, which on its own works totally fine. If I run the game, the cars are going to move. Let me find one. There we go. We have movement. However, this movement depends on the frame rate. Or in other words, if I go to project settings, and then toggle advanced settings, then under run, we have a maximum frame rate, which right now is set to 0, which means we have no maximum frame rate. Godot will try to run the game as fast as possible. Let's say I want to limit the frame rate to 12. That way we get at least a little bit of movement. If I now run the game, will try to run the game as fast as possible. Let's say I want to limit the frame rate to 12. That way we get at least a little bit of movement. If I now run the game, it's going to feel really rough, but the important thing is the cars are moving very, very slowly. If we increase the number to 30, then they should be moving a lot faster. And there we go. Now the taxis are quite a bit faster. And this is a problem. The frame rate shouldn't affect the movement inside of the game. Let's set it to 0 for now. That way, Godot is trying to run the game as fast as possible. Now, to actually fix this, all you have to do is multiply this value with delta time. And then you are done. That's all you had to do. So if I run the game now, the cars are going to move quite a bit slower because delta time is a very low number. So there you can see the cars are not fast at all. Simply change the speed to a larger number, let's say 200. And now the cars are a good bit too fast. Let's go with 100 here. And then we have a car that is moving at a much nicer pace. Really importantly now, if I go back to limit the frame rate to 12, the game is going to be much choppier, but the speed of the car itself is not going to change. And that's the important part. That is the point of delta time. It makes sure that you can change the position independent of the frame rate. A super important concept that you have to use whenever you're changing the position or the rotation or any of these basic properties of a sprite 2D, for example, to make sure that the frame rate doesn't affect the speed of it. However, if you have a physics object that you move via the velocity and move and slide, you don't have to do that. Godot applies delta time here automatically. Next up, we're going to work on the player-car collisions. Or in other words, we have to add a signal to the car that is going to be emitted whenever there's a collision between the two. However, this has to happen inside of the game scene, because there is all of the logic for the actual game. Or in other words, we have to connect the signal once the car is spawned, via GD script. Here we are back in the game, and the issue we have at the moment is that we want to check if the player overlaps with this car, and for that we can use a signal. Body entered would be best. The problem is we can connect this to the car, but then we have a script inside of the car, so in here. I guess that would do something, but it wouldn't really be that helpful. All of the logic for the actual game is inside of game.gd. So in here, I want to run the script for the collisions. Fortunately, what we can do, once a car has spawned, we can connect a signal via GD script. All you need is the car that we have created. Really important, we want the car instance, not the car scene. On that thing, we can run a method called connect. Then we need the name of the signal, which in our case is called body entered. Simply type the string of it, body underscore entered. The second argument is then the function that you want to call, which in my case is going to be go to title, because that's what we later on want to do once there is a collision. Also, really important, I want to pass this function as an argument in here, but I do not want to call it, meaning there shouldn't be parentheses afterwards. We only want to have the word go to title without anything else. After that, I want to create create on one. This is this that we have via GD script. All you need is the car that we have created. Really important. We want the car instance, not the car scene. On that thing, we can run a method called connect. Then we need the name of the signal, which in our case is called body entered. Simply type the string of it, body underscore entered. The second argument is then the function that you want to call, which in my case is going to be go to title. Body entered. Simply type the string of it, body underscore entered. The second argument is then the function that you want to call, which in my case is going to be go to title, because that's what we later on want to do once there is a collision. Also, really important, I want to pass this function as an argument in here, but I do not want to call it, meaning there shouldn't be parentheses afterwards. We only want to have the word go to title without anything else. After that, I want to create this function. So func go to title. No need for parameters. And now, once that is the case, I want to print player car collision. And that should be it. Let's try. Inside of the game, I am getting a lot of errors. You can see in the bottom bottom, Godot is really, really unhappy with us. Under errors, we are getting an issue, and let's read it out. Godot has an error calling from signal body entered to callable go to title, the one that we have just created here. And the issue is, the method expected 0 arguments, but was called with 1. Understanding these error messages is incredibly important, so let's go through it. Go to title expected 0 arguments because there's no parameter. However, because of connect and body entered, we are calling this function with 1 argument, this number here at the end. Effectively, when Godot is calling this function, it passes an argument into it, but inside of the function, we don't have a parameter. And as a consequence, we're getting an error message. This happened because, however, because of connect and body entered, we are calling this function with 1 argument, this number here at the end. Effectively, when Godot is calling this function, it passes an argument into it, but inside of the function, we don't have a parameter. And as a consequence, we're getting an error message. This happened because when you look at the signal, body entered, we are getting the body as an argument passed into it. And this is what Godot wants to do. To fix that, all you have to do is add 1 parameter, which would be the body. Although in our case, we don't really care about it. But just to demonstrate what is happening, let's print the body that we are getting. And if I now rerun the entire thing, we are getting a whole bunch of collisions actually. Let's have a look at the output. The first collision that we are getting is a static body 2D collision. Then we have another static body collision, another one, and then we have the actual player collision. We are going to work on that in just a second. But for now, the important thing that you have to understand is if you want to connect a signal via GD script, You get the node or the scene you want to connect, then you call connect with the signal name, and then the function you want to call. And always make sure that you are counting for all of the arguments that Godot is passing into this function. And once you have that, you can connect signals via GDScript. Now, besides that, we were expecting the player body and player car collision, simply the string. However, besides that, we got a whole bunch of additional collisions. What happened here? When we are looking at body entered for the area 2D, it looks at any body. This would include these borders around the screen. Static bodies are still bodies. So whenever a car is being spawned, it will collide with this border. A car could also collide with the tree that we have created, and it could also collide with any other object that we might create, which at the moment isn't really the desired behavior. So how can we fix that? For that, we have collision layers with any other object that we might create, which at the moment isn't really the desired behavior. So how can we fix that? For that, we have collision layers. Effectively, every physics body has a layer and a mask. A mask is determining what physics object a node can see. And a layer determines what other physics objects can see the node. That way, for every single physics object, you can determine which objects can see each other. So with that, back in Godot, if you look at any physics object, like for example the player, in the inspector, under collision, we have layer and mask. All of these are just numbers, and this determines what layer and what mask the player is on. If you have over these numbers at the moment, you only get layer 1. But what you can do under project, project settings, and if you scroll down a bit, somewhere we have 2D physics. And let me disable advanced settings. We don't need it anymore. In here, you can name all of the various layers. For example, we could have layer 1 being terrain, layer 2 being the player, layer 3 could be the cars, and layer 4 could be the walls. And by walls, I mean layer 4 could be the walls. And by walls, I mean these walls around the screen. And to get started with the player should be on layer 2, or could be the walls. And by walls, I mean these walls around the screen. And to get started with the player should be, and layer 4 could be the walls. And by walls, I mean these walls around the screen. And to get started with the player should be on layer 2, which is only for the player. So this determines what other objects can see the player. And on the flip side, for the mask, the player should be able to see the terrain, he should not be able to see itself, the player should be able to see the cars, and the player should see the walls. Then for the tree, for collision, the tree should be on a terrain layer, and for mask, we can disable everything, simply because the tree doesn't have to see anything else. And just to demonstrate, if I now run the game and go to the tree, we are still getting a collision, and that is working pretty well. However, once I put the tree on a different layer, let's say layer 5 that we are not using, then the player can walk right through it. There's no collision anymore. The only layers that the player can see are determined by the mask 1, 3, and 4. If the tree is not on any of them, the player is going to ignore it entirely. All of this you should really practice. The player has no collision, but we are still for people to see the terrain, the player. And on the flip side, for the mask, the player should be able to see the terrain, he should not be able to see itself, the player should be able to see the cars, and the player should see the walls. Then for the tree, for collision, the tree should be on a terrain layer, and for mask, we can disable everything, simply because the tree doesn't have to see anything else. And just to demonstrate, if I now run the game and go to the tree, we are still getting a collision, and that is working pretty well. However, once I put the tree on a different layer, let's say layer 5 that we are not using, then the player can walk right through it. There's no collision anymore. The only layers that the player can see are determined by the mask 1, 3, and 4. If the tree is not on any of them, the player is going to ignore it entirely. All of this you should really practice. For that, set up the layers and the masks for the cars and the walls. Really important, the cars should not see the walls or each other, but they should see the player. Pause the video now and see how far you get. I want to start working with the car, specifically the area 2D node. For collision, the layer should not be on terrain, it should be on cars. That way the player can see it. Next up, for the mast, the car should only be able to see the player itself and nothing else. That way a car should already not see the walls around the screen anymore. Let's try this, and now we should only get a collision between the car and the player, and that looks pretty good. Finally then, for these static bodies around the screen. You could leave them on the terrain layer. It would kind of be possible, but I would rather have this organized, so they should be on walls and they should not see anything else. This I want to do for all of them, so this should be only 4. Same for this one. And same for the final wall, only on layer 4. That way the player should still say for all of them, so this should be only 4. Same for this one. And same for the final wall, only on layer 4. That way the player should still see them. There we go, this works. But the cars are going to concept. Alrighty, let's going to teach you all of the important parts of Godot to create. That being said, type object. The second one you want to download. So our game is coming together quite nicely, but there's one it's really whatever doesn't move and needs to be collided with 2D. Moves and the own, it doesn't important thing. Godot is going to complain that so of the player with a collision shape. So inside of this player is not able to leave. This we have to do for all of the 4 sides. Although you do have to be careful. If I simply duplicated this static body 2D by clicking on duplicate or Control D, then we would get another static body 2D that we can move to this point here, and that would work. I can now run the game. Are going to ignore it entirely in 2 different ways, actually. With that system, we can control a lot better what is colliding with each other. Finally, all the way at the top, we have the finish area 2D. This one should not be on any layer. Or in other words, no other physics node should be able to see it. However, it itself should be able to see the player. That way, if I run the game again, the player should still be getting up here, and that works, but no other physics object can interact with it. At this point, we have covered all of the basic concepts to create a level. If you added lots more stuff to it, you would have a pretty decent basic game. And this is what we are going to do in this part. However, before we get to it, there's one important concept that I still have to cover. At the moment, the player can either be behind an object or in front of it. But this system is static. The player couldn't dynamically change the position. Back inside of Godot, the position of the player relative to the tree, these two objects, is determined by the node tree. So at the moment, the player comes first, and then we have the tree. And as a consequence, if I move the player around, the player is always behind the tree. Inside of the game, you can see that the player right now is in the right position, behind the tree. But if we go around, now the player is, well, still behind the tree, but the player should be in front of the tree. That we have to fix. The system for that is called Y sorting. All that it does is it decides which object is going to be on top depending on their Y position. Just imagine that this line up here is Y being 0. The player position in this case is, let's say, 10 pixels, and for this player it's going to be 20 pixels, while the car is always going to be on pixel position 15. Same for this one. All that Y sorting is doing is it compares these two numbers. Whichever has the higher Y number is going to be drawn on top. That way, if the car is further down, it's going to be on top of the player. If the player is further down, it's going to be on top of the car. And that's literally it. It's a really simple concept, and you can apply it to Godot super easily. All you have to do is grab the parent node, objects in this case, and then go to ordering inside of the inspector. There we have Y sort enabled. This should be enabled, and then all of this is going to work. So the player can be behind the tree, like so, and the player can be in front of the tree, like so. And that is feeling a lot more realistic. And by the way, it's really important for this system that the collision shapes for the player and the tree don't cover the entire height of the object. For the tree, we have a bit of space at the top, and all of this is going to work. So the player can be behind the tree, like so, and the player can be in front of the tree, like so. And that is feeling a lot more realistic. And by the way, it's really important for this system that the collision shapes for the player and the tree don't cover the entire height of the object. For the tree, we have a bit of space at the top and the bottom, and same for the player. We have And well, with that, we have the basic system in place. Now we can add lots of objects. To place all of these elements, you want to organize your project so the entire thing is reasonably streamlined. Let's do some examples. We already have one object, the tree, where we have a static body 2D, a sprite, and a collision shape. We could, for example, copy this tree and then place it here and here and here, run the game. We would have more trees. Static body 2D, a sprite, and a collision shape. We could, for example, copy this tree and then place it here and here and here, run the game. We would have more trees. Pretty straightforward. If if you wanted other objects, all you would need to do is create another static body 2D node. Let's say for this one, I want to create a box, for which I want to go to graphics, and then inside of objects, we have a couple of boxes. I want to choose one of those. To add it to the scene, I want to add a sprite 2D, and then box.png is going to be the texture. After that, zoom in quite a bit, add the collision shape 2D. For this one, we definitely want to have a rectangle that we then want to scale down quite a bit to something like this. Afterwards, save the entire thing inside of scenes, box.tscn, and then we have a box that once again we want to attach to objects, which means in there box.tscn, and then in the origin point we have a box. And by the way, if you try to move it and you move something else, like for example right now the car start positions, you can avoid that by having the box selected inside of the scene tree and then hold Command or Alt. That way you are only moving the node that you have selected inside of the scene tree. Can sometimes be super handy. But anyway, once we have that, we have a box, and then inside of the game, we can collide with it. That being said though, for something as simple as a box, this is kind of overkill, because a box is, well, really simple. We don't need a separate scene for that. What we could also do inside of objects is simply create another static body 2D that we could rename to, let's say, bench. To this bench, we can add a sprite 2D right away. And for that, I want to use bench.png for the texture. Then we have a bench, and after that, we can add a collision shape 2D with a rectangular shape that we then want to scale, like so and so. And then we have another object that we can work with, and we didn't have to create another scene. Although you do want to be careful. Moving this bench around right now can be kind of annoying. There's a good chance that you accidentally only drag the collision shape or only the sprite 2D, which would, well, cause a ton of problems. So this I don't want to do. To avoid that, you want to click on this symbol. If you activate it, you're getting this symbol next to the node. That means you can only move the parent node. So now we are always moving the entire bench as one object. Super handy. That way we can move it, let's say, here. And once again, inside of the game, we are getting another object that we can collide with. There are loads of useful icons at the top. The other one that's super useful is locking it. That way, this node cannot be worked with anymore, which, for example, we really want to do for the background, because this one really isn't supposed to move. Same with the borders, actually, and with the car start positions. None of those should ever really move. Although the bench shouldn't be locked, but it should be grouped. This would be another way to create an object inside of the scene. Once you have that, you can simply duplicate this bench, and then you can create as many benches as you like. Which is also a way to approach it, although if you want to create a lot of objects, this might still not be ideal. For that, we can approach these kind of objects in a different way. Let me add another node 2D, where I want to have a whole bunch of, let's just call it stuff. Doesn't really matter what you call it. To this node, I want to add lots of random sprites. I can simply drag them in there, like so. There we have a bin. We can put a box here, a box there, a third box here. Let's say we can put a car in this position and a light here-ish. The specific shape does not matter. I just want to have a whole bunch of sprites inside of the stuff node. And make sure that for this stuff node, you have ordering Y-sort enabled. Now we have a whole bunch of objects. The problem is, inside of the game, we have no collisions whatsoever. For that, we will need a static body 2D. Now what you can do to a static body 2D is add multiple collision shapes. which means I can add a collision shape 2D with a rectangle for now. And let's say this one is just for the car. So I can resize it to something like this. And then to the same static body 2D, I can add another collision shape or collision polygon.